Okay, so energy we've been talking about is the ability to do work. You have kinetic and potential energy. So what does it work then? Work is energy transferred by force. So energy, potential kinetic energy is ability to do work. Work is how do you transfer that energy from one type to another, and it is transferred by a force. Okay, so work is capital W, and it is force times distance. So what this tells us is this energy is the ability to do work. Well, work is force times distance. So anytime you're moving an object that is traveling over a distance, that involves work. So the energy, the ability to do work, is the ability to move an object. So if I lift something, I'm moving it. That requires work. That work will change the energy of the object. So if I lift something up, right, we know potential energy is going to increase. We know to move it requires work. Okay, so the work is causing the change in potential energy. Okay, if I want this object to go faster, right, that means I'm changing the kinetic energy. That is going to require a force over a distance, which is work. So our units, force of course is in newtons, distance is in meters. So Newton meters. The nice thing about that, of course, this is equivalent to a joule, which we know are the units for energy. Now, a couple of things that we want to think about with work is that the force and the distance, the direction of the distance, must be parallel. Which I just realized I believe I spelled that wrong. So hold on. There's only one R, parallel. So force and distance must be parallel to each other. So force and distance must be parallel. If they are perpendicular to each other, so if I push to the right and the object moves up, let's say, no work can be accomplished. No work. So they must be in the same direction, if you will, or parallel. It doesn't have to be the same direction. For example, force to the right, the direction of the movement can be to the left. And that means that friction can do work. And it does. Changes the energy in an object. That's what friction can do. Okay, so if we just scroll a little bit here, couple other things here we want to, of course, look at is, you know, if you apply a force, the force increases, but the object does not move, right? No work. Work is force times distance. So if the object doesn't move, there's no work. So if I push against the wall doesn't move, doesn't matter how much force I apply. If the object does not move, no work. There will be no change in energy. Another thing is positive work increases the energy. Negative work, of course, decreases the energy. Okay, so why don't we look at some problems here that involve work and energy. All right, so some of our equations: work equals change in kinetic energy. So that would be force times distance equals 1/2 mass velocity squared final minus 1/2 mass velocity initial squared. So what this is telling me, remember, if you want to change the amount of energy of something, it requires work. So you triangle change kinetic energy. So your final kinetic energy minus your initial kinetic energy will give you the work. Now in CP physics, usually, our initial velocity will be 0. So our initial kinetic energy can be 0 as well. Don't forget also that kinetic energy can equal potential energy in certain situations. And so we can have basically all of these things equaling each other in very specific situations. Okay, so let's look at a sample problem here. So if we look at this problem, how much work is needed to lift a 10-kilogram barbell 5 meters? So we know mass. My pen decides not to work again. Mass is 10 kilograms. We know distance will be 5 meters. And we're trying to find how much work. So we know work is force times distance. Well, when you lift a barbell, what is the force? Well, the force is the weight, and we know that weight is mass times gravity. So weight is 10 kilograms times 9.8. So we know our weight is 98 newtons, and weight is a force. Now, it is a little confusing because we're using W for weight when we are also looking for work. So I know a lot of textbooks for weight will do FW, which kind of makes sense since you are eventually going to learn about work. But I just keep it as a W. You just got to know which one you're looking for. So now our work is going to be force of 98 newtons times our distance of 5 meters. So 98 times 5 is 490 joules. Work is in the same units as energy. All right, let's look at another sample problem. So here's another sample problem I would expect you to be able to do on a test or a quiz. A 5-kilogram can is pushed 10 meters across the table with a force of 12 newtons. How fast was the can moving after 10 meters? So we know mass, 5 kilograms. We know distance is 10 meters. We know the force is 12 newtons. And we want to know the velocity. So we know work equals the change in kinetic energy. Work is force times distance. Kinetic energy is 1/2 mass velocity squared. Now it's the change in, so technically it's final minus initial. But I think, since it's CP physics here, we can definitely assume that the starting kinetic energy is 0. So now we have force times distance equals 1/2 mass times velocity squared. And we want to solve for velocity. So our force, 12 newtons, times a distance of 10 meters, equals 1/2 our mass of 5 kilograms. And we will solve for velocity. So we have 120 equals 2.5. velocity squared. Divide by 2.5 and we get 48 equals velocity squared. And take the square root of 48 and our velocity is 6.9 meters per second. So I will give you the formulas on the quiz. You just have to know how to use them and how to substitute them in. But remember, work is what we use to change the energy. Energy is the ability to do work, to move an object. And they're kind of synonymous and very similar to each other. And it's just really about, context and syntax and just very subtle differences in their definitions and things. If you lift something up, you change the potential energy, that was required work. If something speeds up, that requires work because you are changing the kinetic energy. Okay, so practice on your own there. Khan Academy has some good videos. PhysicsClassroom.com has good information. And let me know if you have any questions.